All right, let's turn on our Commodore now, 128. The first thing it does is access the disk to load the CPM. As you can see, booting CPM plus data table 59 TPA. And here it is loaded, as you can see, CPM 3.30 with the applications. And here we are. In CPM 3.0 mode with 40-column display. Now there was also the possibility here, but today it's no longer possible to use a monitor with an RGB input. That way I could have also shown you the 80-column mode. All right, never mind, I'll send it in for repairs. Anyway, stay with me. Because now, besides basic, at the end, we'll also add some more information about the 128 CPM. All right, now that we've seen the introduction with CPM, and we'll talk more about it. Then at the end of the video, with some technical information, we'll get back to some software details, and in particular, today we'll look at some programs that handle strings, some commands, of course, from the Commodore Basic 64. In this case, I enter Claudio, and of course it tells me not found, but I don't remember anymore. What is the name? Maria. That's absolutely perfect. We will run it again. Let's say we meticulously enter Maria here, and at this precise point, it successfully finds Maria. But let's take a closer look at some of the specific and important commands of the Commodore computer system. 128, because as you can see, here I've listed the classic commands that BASIC has, hash, left, mid, right, len, string, and chars, and that's normally in BASIC 2. Today we're going to look at a command that's typical of BASIC 7.0, which is instr, and basically with this command it gives us two results. First of all, it allows us to find one string within another string, and that's already quite remarkable. Even back then, it reminds me of the substring function in C. But it's also true that on further analysis, as we'll see, it actually returns the position of the first string found within the second one. And that's definitely not a small thing, especially because it can be done with a single command. But that's not all, because I tried to combine business with pleasure. And so basically, besides these strings, I also tried to combine them with some other additional commands. Basic 7.0, obviously, what does instr do? We can say that within the string, in the string, it receives this first string, which, so to speak, can be a string target. And this is the second string, which is the string I use to search for it within a main string. Now, of course, I was also interested in trying this, which is a new type of loop, and adding two essential features. So as you can see, 7.0 doesn't really have structured programming inside yet because it's still made up. Thanks anyway. From the obscenities like goto, however, it starts to introduce what are, and this is a Pascal construct, the do loop or do while from C. But what characterizes the 128 is that with a view towards somewhat more advanced programming, it brings back all the back-end aspects of Pascal, or at least block logic. So here it performs a loop until, meaning it exits when it basically returns a true value, indicating that this instruction has been found. And here, basically, it does just that. We have the primary input mechanism for the name, and it meticulously reads all of these essential values through the various and distinct data statements, which are conveniently located right here. And when fundamentally there is absolutely no name provided, that is precisely when, quite clearly, the sleep function diligently puts the central processing unit to sleep for a duration of 2 full seconds. And then in any and all cases, the entire program ultimately comes to its conclusion. It's worth noting that there's this additional instruction, which we can think of as a try catch, so something that already allowed for error catching. It can be applied to inputs, but it can also be applied to things like division by 0, and it basically intercepts possible errors. If this condition occurs, it immediately triggers a trap door, and jumps to location 95. Nowadays, we can see what the construct of raising an exception is, as we've also seen in the GPS Plus course. Try, throw, catch. The logic is more or less similar. Clearly here it's much more simplified, but the concept is the same. But let's also look at other possibilities, still within the program itself. So let's look at the second part that starts here as I promised. Program in run. At this point, let's put it all together. Screen, I had forgotten to include that. Letter A, attention, letter number 11 found. So here, there are also two things to say about this instruction. First of all, this is the target string. And as you can see here, we only have hexadecimal digits, and I'm basically telling it to provide me with one. That is a hexadecimal digit, which goes from 0 to 9 or from A to F. Clearly, it either finds it or it doesn't, and these are the various conditions. This instruction is also able to return the actual position of the character, but be careful because the position of the character itself is 11. Why does this happen? Because it's basic. And in basic, the first position is number 1 in this case. But here, the position of character 0 is not allowed. And that's something that will be signaled. Keep that in mind. And so let's move on to our third example. Because here I took into consideration the sorting algorithm, and I also included two additional instructions. We can run the Commodore 128 in fast mode, or we can run it in 128 in slow mode, meaning at 1 or 2 megahertz. Clearly, this is possible by enabling these two types of instructions. And again, in this case, we access the arrays practically starting from number 1 onward. Let's run the program for a moment. This program should perform a sorting. As for the strings, we can use C, which should be the last one, A, which is the one in the middle, and it could also be B. And as you can see, it has sorted exactly A, B, and C. And then by pressing a key, of course, we exit here. Now let's go back and do another build. At this point, basically nothing changes. CB, but as you can see, it's noticeably faster. We can also stop it at any time, of course. Here with CBA, you don't really notice the difference. You'd need a slightly faster array. However, as you can see, I have enabled what are the fast and slow instructions. Now, I included this for the sake of correctness. It's not that you can't access element 0 in arrays, but I've noticed that while it's a modern practice today, back then it wasn't always possible to access an array starting from element number 1. And in fact, the original program I took from a book, as you can see, accessed the array element, but starting from position 1, and that was it. Then here it does nothing more than a simple bubble sort, so it basically keeps swapping the array. And it has a very nice feature. If this condition doesn't occur, it goes straight to the next step, but thank you. If the condition is met, it goes back, but it goes back exactly to repeat the cycle from the beginning. And this was still one of those old tricks that would obviously make you smile today, but they were extremely important at the time because with very little code and a remarkable programming skill, especially because they came from assembler, allowed you to achieve even these little tricks with just a few lines. And then nothing special, we have this getAs, which unlike input, which puts a question mark where the character is, here it's basically like an in case. It waits for a key to be pressed. And if this clearly, there's nothing. So basically it's a string of work. It returns to line 720 until a key is pressed. What can I say with this short program? But we've taken a look at some typical instructions of what is BASIC 7.0. Obviously, as I mentioned in the first video, for those who come to BASIC 7.0, it's obvious afterwards, especially for those who already know 2.0. And here we have the addition of a few commands and also some extra information. So we're not going to go over the same basic again, but we'll see more. Gradually, we'll always look at aspects that are a bit more important, a little more complex until we eventually get to graphics, music, bank management, and so on. All right, let's get back to some of the information we presented earlier. The 128, 3 with plus 3 and 1, so COM64, 128 thanks to the MOS 8563. And as I previously showed you, we have the CP/M operating system mode, which, so to speak, is a very old disk operating system that, thanks to the Z80 processor, could still effectively operate and function, and then be made compatible with MS-DOS programs. let's say it could potentially start up in either a 40 column or an 80 column display mode. We observed it running effectively in the 40 column mode. On the other computer, actually, on the other Commodore 128, I can get it to run in 80 columns, but it requires a special cable that connects to the VGA. We saw this in the previous session. As we were saying, on one hand, the choice to equip it with CP/M 3.0, we saw that version 3.3 was slower than 2.2 because it had undergone various developments over time and several unified releases. Also, the fact that the Z80 ran at 2 MHz instead of the more common 4-6 MHz found in competing hardware. But it ended up being one of the slowest implementations. It was actually planned to run at 4 MHz with 80 columns, but that never happened. It should be said that CP/M was, in fact, a real operating system. And just like DOS, but here we have to remember that CP/M worked with disks. So the disk I showed earlier is double-sided, so it could read both the front and the back, especially with the 1571, which I'll cover in a video. We'll go on to analyze some features because only the 128 was able to make it work at its best. The 1571, however, even though the first IBMs already had hard disks here, basically the management was all about the disks, as I showed you earlier. And so this was really a handicap because reading, writing, and management were all really slow. Then, well, here it talks about the double-sided 1051s and so on. By the way, I wanted to show you a little gem before wrapping up the video. Basic 7.0 also contains some unimplemented commands that come from the old BASIC implemented on the Commodore LCD. In fact, if we type quit or off, we get the unimplemented error here. As you can actually see, both quit and off are there. They exist, but they are unimplemented command errors. You see, it's a really nice touch. As for CP/M, what else can I say? I could certainly show how it works, but that would clearly require a separate video. Here, we've just done a brief overview. As for basic programming language, CP/M operating system, and some other hardware features of this machine, we'll come back with more videos, still focusing on the Commodore 128, its basic environment, its software, and its hardware. And maybe even some additional news as well. So thank you very much for staying with me up to this point, and I'll see you next time right here on Project CD Chronicles, Claudio.